Good morning, friends. Today, we are going to discuss on hypothesis testing. This is Dr. Vijay Joshi here. Introduction to hypothesis testing. Hypothesis testing is a statistical method which is used to make decisions based on sample data. It helps determine whether a claim about a population is likely to be true or not. Used in research, business, medicine, and various other scientific fields. In India, it is applied in the various fields like economic surveys, medical trials, and then policy making, and so on and so forth. So, hypothesis is basically an assumption where a researcher tests his assumption using a hypothesis. So, let us understand the key concepts in the hypothesis testing: population versus sample, statistical inference, and then confidence level, and then the significant level, which is denoted by alpha. There are different types of hypotheses. The first one is null hypothesis, and the second one is alternative hypothesis. Null hypothesis is denoted by H naught, which assumes that there is no effect or there is no any difference between the two samples or the two means of the samples. Alternative hypothesis H1, or also represented by HA, indicates a significant effect or difference. We can understand this with the help of an example. H naught, the new agriculture policy has no impact on farmers' income, whereas alternative hypothesis states into the opposite way. So it says that the new agricultural policy significantly increases the farmers' income. Usually the H naught, that is the null hypothesis, is always opposite to the researcher's assumption. The alternative hypothesis supports always the researcher's assumption. So that is the difference between the null and alternative hypothesis. With the help of data and statistical analysis, either we prove or we disprove these hypotheses. And then how to do the steps in hypothesis? The steps in hypothesis are and so on and so forth, as we can see here. So first step is to formulate the H naught and H1. So we need to clearly define what is the null hypothesis and as well as what is the alternative hypothesis. Here in this example, H naught is the null hypothesis, which is stated as a new fertilizer did not increase any crop yield. But whereas H1 signifies that a new fertilizer will increase the crop yield. So this is an assumption and there is an opposite view against the assumption. So the next step, that is the second step, is to select the significance level, that is alpha, which is typically at the level of 0.05, that is at the 5% significance level. So this determines the threshold for rejecting a null hypothesis. A lower alpha, that is example 0.01, reduces the risk of the type 1 errors but increases the type 2 errors. We will understand the type 1 and type 2 errors into detail in the following slides. To choose an appropriate test statistics. So the next step is based on the data type and the distribution, we need to select a test that is an appropriate test. The test would be a t-test, a z-test, or a chi-square test, or it can be an analysis of variance that is denoted by ANOVA. So, for example, a t-test is used to compare two means while a chi-square test is used for categorical data. So the next step is to compute the t-test and then p-value. Perform calculations or use statistical software to find the test statistics. So we can use the calculations manually, or we can also use the statistical softwares like SPSS and so on and so forth to find out the t-statistics. And then compute the p-value, which indicates the probability of obtaining the observed result of H naught is true. The next step is compare the p-value with alpha and then take the decision. So if p is less than alpha, then we have to reject the H naught, which provides sufficient evidence to support our alternative hypothesis, that is the H1. If p is greater than alpha, then we should not reject the hypothesis. There is no insufficient data or evidence to provide to support the null hypothesis, that is the alternative hypothesis, that is H1. For example, if p value is 0.03 and the alpha is 0.05, then we need to reject the null hypothesis, concluding that with the previous example that the fertilizer significantly increases the crop yield. And then there are types of errors which are possible while testing the hypothesis. These errors can be classified into two things, that is type 1 error and then type 2 error. So type 1 error is also called as false positive. This occurs when H0 is rejected even though it is true. For example, a code convicts an innocent person. So the probability of type 1 error significant level, that is alpha, are commonly set at 5%, that is meaning a 5% chance of wrongly rejecting a null hypothesis. Then there is another error called as type 2 error, which is a false negative error. So this occurs when H0 is not rejected even though it is false. Example, a guilty person is acquitted in the court. So this is the probability of type 2 error, again depends upon the sample size and the effect of the size. So lower alpha increases the risk of type 2 error. So there is always a trade-off between the type 1 and then type 2 errors. The reducing type 1 error, so that is lower alpha, increases type 2 error and then vice versa. So a researcher needs to balance. A balancing depends upon the context, that is medical trials prioritize minimizing the type 1 errors, whereas industrial quality control may focus on reducing the type 2 errors. So this is again basically depending upon the area of research what we are looking at. So then comes the significance level and then p-value. As we have already discussed, that significance level is the probability of the rejecting the null hypothesis when it is actually true, that is type 1 error, commonly used with the levels of 0.05 or 5%. So the p-value measures the probability of obtaining a test statistic as extreme as the observed one is under the H0. So a small p-value suggests a strong evidence against the H0. So ultimately, we need to interpret the results as P is less than alpha, then reject the null hypothesis, and then support the alternative hypothesis. If P value is greater than or equal to alpha, then fail to reject the null hypothesis, and then there is no even insufficient evidence to support our H1. An example could be a study test whether the new government digital literacy program increases smartphone usage in the rural areas. So here in this example, the H0 would be the program has no effect, and H1 would be the program increases smartphone usage. So after analysis, we can conclude if the p-value is less than 0.05, that is alpha, so the program is significantly increasing the smartphone usage in the rural areas. The another example would be the common statistical tests which are used are Z-test, t-test, chi-square test, ANOVA, and then non-parametric test. These are used for different types of samples. So when we have large samples, we are using Z-test, and when we are for small samples, we are using t-test, or when the population is unknown, variance is unknown, and the chi-square test is used for categorical data. When we do not have any numerical data, so we are using the chi-square test. And the non-parametric test when data does not meet normality assumptions, so we are using non-parametric test. So decision-making process could be one-tailed or two-tailed test, interpretation of results, and then practical versus statistical significance. So decision-making process is based on one-tailed. Suppose we are testing on the one side, either on the positive or the negative side, when we are using one-tailed test. When you are using on the both sides, then it is a two-tailed test. So finally, we need to interpret the results and then try to give an interpretation on the basis of the statistical significance. One example here we can see is that the mobile data plans in India. So here we can see that the mobile data plans in India hypothesis that two discounted mobile data plans increase the internet usage among the students. Sample data is data consumption before and after the discount. Statistical test, the appropriate test which can be used here is a t-test for paired samples. The conclusion would be on the basis of the p-value. If p-value is significant, the inferences we can draw is that the discounts lead to higher usage. So finally, we can conclude by saying that hypothesis testing is an essential for decision making. Understanding errors and statistical significance levels is crucial. To choose appropriate tests based on the data and based on the data characteristics. Interpretation should be considering both statistical and real-world implications. Hypothesis testing plays a crucial role in policy evaluation, business decisions, and healthcare research. With this, we are going to conclude this presentation. Thank you.